Hello, science students. We are in Concord Consortium flood module on activity 5, page 5. Let's rock and roll. Future floods. An increase in heavy rainfall due to climate change and an increase in developed land make the work of flood mitigation engineers difficult. So flood mitigation is trying to keep floods from overwhelming people's houses and keeping people safe and infrastructure safe, like keeping our bridges from flooding. Can people in their communities be protected even when extreme rainfall and urbanization continue into the future? Remember, urbanization is just getting more cities in an area, so we have less permeability. Use levees in the Flood Explorer to try to protect important areas of future Silver City in the extreme rainfall scenario. Can levees help reduce the impact to people in extreme rainfall conditions? You can only build 10 levees because building levees is expensive. Add 10 levees to minimize the impacts of flooding for as many people as possible. Set amount of rain to extreme, storm duration to long, and starting water level to medium. So extreme, long, and medium. So here we go. Extreme, long, medium, and let's flood this so we can kind of see where we need to focus on with levees. And I realize that it's pretty tough if you're working on an iPad to place the levees. The Flood Explorer gets a little cranky. So you can watch me and take a screenshot of this if you need to. So let's go back and figure out where the rivers are the most flooded. And if you can do this on your own, it's kind of more fun to do it on your own if you can. So let's get ready to place levees. So click levees, and let's figure out what we need to protect first. If we want to protect the hospital, we probably have to get the levee all the way before the hospital and after the hospital. Otherwise, water tends to work around the levees and infiltrate the hospital. So if we want to protect, we have to figure out right now if we want to try to protect the retirement village here or the airport, because we only have 4 levees left. The airport's looking pretty dry right now, but the road's pretty wet. If we put levees on this side, we're going to flood the road, but we don't have enough levees to protect the road as well, unless we put levees all along here and we let the retirement village flood. So there's some tough decisions you can make as a community. You can see that communities can be really torn about who they need to protect because they have very limited budgets. So let's restart and rerun this. And we're supposed to take a snapshot with gauge 3. Remember that gauge 3 is on the other side of the river from the hospital. But we can see here that here's the side without levees, and here's the side with the hospital and the levee. So let's let it run here and see what happens to the side with the levees. It looks like we're doing okay so far. Looks like the hospital and the retirement village got a little bit wet there. So let's take a snapshot here. Let's go back a little bit so we can get maximum flooding. The levees must have been breached here, or the water must have come around at the top of this levee. Scroll down and take a snapshot. Here's our snapshot. You can clearly see the levees we put, and you can see that this side flooded. It went above flood stage, this red line here, but this side was okay. So, were the levees you built effective in protecting the people of Silver City in the extreme rain experiment? make sure to check all 3 gauges during the flood. So the gauges are on the other side from the levees. So here in the retirement village, this side flooded, the undeveloped side, but the retirement village looks at least like it was less inundated. It had less water, but it didn't completely protect them, so maybe it was a bit of a failure here. Maybe the retirement village is just built on very low, kind of swampy land, and it gets, the water table comes up and floods the retirement village anyways, no matter what we do. It looked like the hospital stayed dry, so we were good there. We didn't build any levees around gauge 2 here. We did flood the town here, but not the farm. It seems like if people would have been wise a long time ago, they would have put the town on the over here and the farm over here. But we can't really change that. So were all the people protected? Some people were protected, but others not. None were protected. So obviously we flooded some people here at stream gauge 2. We didn't even think about some of the houses that might be over here. So there's your answer to question 17. Based on your snapshot and your examination of all 3 gauges, explain your answer to the previous question. So our claim here, I'm going to say that some people were protected and others were not. So my claim is some people were protected and some were not. You can put whatever claim you're using and then use your evidence. My evidence would be that I saw at gauge 1, the retirement village had some inundation, and at gauge 2, the people living across the river from Hidden Valley Farms also had some inundation. So there were people, my evidence is there were people not protected. My reasoning is that we can't put levees everywhere, and we can't always protect everyone. We have limited budgets. Describe any unintended consequences the levees you by the levees you constructed. Well, let's go over here and look at the gauges again. So there were no levees constructed here, and we still flooded the town, the folks who live across from Hidden Valley. We probably flooded this uninhabited area here, the undeveloped area where there are no buildings. That's not a big deal. When we put the levee here, we might have flooded out this parking lot. And hopefully everybody was smart enough to move their car, but maybe not. We don't know. When we put in levees, it probably floods a little bit more on the other side. The retirement village flooded no matter what we did. Like we put in 4 levees around the retirement village, but it still flooded. So for me, my intended consequences with my levees were the retirement village still flooded. And that seems like a flood mitigation failure to me, because we didn't protect the people we were trying to protect. All the old people got wet. It didn't wash away, but there was inundation and people's homes would have been wet, their basements would have been full of water, there would have been a lot of damage, and it's hard for older people to deal with catastrophes because they have limited energy and sometimes limited resources. Explain how extreme rainfall and urbanization increases the challenge of protecting the people of Silver City from the flooding. Well, the more people living next to the river, the harder it is to protect them all. So I'm just going to put some points that you might want to include in your argument. So more people live next to the river. So that's more people to protect. 2, there's more pavement. There's less permeable surfaces. So every time you build a parking lot, you get kind of like twofold. Water that falls on the parking lot runs off, so that adds, and then the water that falls on the parking lot doesn't soak in. So more pavement, less permeable surfaces, more water running off, and more flooding. And then extreme rainfall means more rain at once, which is difficult for flood mitigation systems to deal with. My cousin is actually a civic engineer in the city of Portland. She helps plan their rainwater and storm sewer plan. They're starting to get more extreme rainfall events like everyone else, and they're starting to plan for that. And it's difficult. When you get 10 or 15 inches of rain in a day, that's really hard for all the existing storm sewer systems, those grates in the street that you see that where water flows in when it rains. It's difficult for that system to deal with. So we have to be creative in trying to get more of the rainwater to soak in and not run off to our stormwater systems. All right, let's continue. Putting it all together. At the beginning of this module, you're asked to think about the question, how will flood risks and impacts change over the next 100 years? Because people who are planning towns need to think ahead. If you're going to build a bridge or a road, you really need to think about how will this be impacted by flooding or extreme rainfall events. Cedar Rapids, Iowa is one town that's working hard to answer the question. Cedar Rapids has seen some devastating floods in the past few decades. The city is shown on the map below. Scientists use a model to create this flood hazard map, showing which zones of the city are susceptible to different sizes of floods. Now, scientists probably have a little bit more sophisticated model than we do, but that's the kind of things that scientists do. They use models like Flood Explorer. They build models like Flood Explorer to help cities plan ahead for climate change and for increasing urbanization. In the map below, the dark area is the red is the river. So let's look. Here is the river in the darker red. The pink area right next to the river, that's the 100-year floodplain. So this area is likely to flood in the next 100 years, or maybe sooner if we continue to get these extreme rainfall events. The blue area is the 500-year floodplain right here. And we know that one city in Iowa has already had 5 100-year floods in about 25 years. So they maybe need to plan for those 500-year floods. In the light of climate change, how might this hazard map look different in 100 years? If we get more extreme rainfall, increasing urbanization, if our water tables are higher, our starting water levels are higher, all of those things can affect how we plan. So would the 100-year floodplain expand, but not the 500-year floodplain? The 500-year floodplain would expand, but not the 100-year floodplain. Both would expand or no significant changes. You can make up your mind. Think about what you've learned in this module concerning climate change and flooding. Which of the following is likely to occur in Cedar Rapids in the future? More frequent and more extensive flooding, less frequent and less extensive flooding, more frequent but less extensive. That means the floods occur more regularly, but they don't flood as much land. Less frequent but more extensive. It happens less often, but it covers more area. So you can choose here, but remember, we have more extreme rainfall. We have more people living next to the river. We have more pavement, which affects the permeability. We may have higher starting water levels because we have increased rainfall all over the Midwest. So we've got a number of factors that kind of vote for more flooding. If you were a city official in Cedar Rapids, what changes would you suggest to decrease the risk of flood impacts in the future? Well, it's hard to get people to move. There's a lot of people who live in the floodplain. But I would say, if I was a city engineer, I would say I would try to get people to, there would be no new construction here. You can't build any more houses in this area. Now, that would raise some eyebrows and probably lead to some protests, but in the end, it would probably be a good idea. I would try to develop parks along the edge of the river, so if they flood, it's not a big deal. You know, don't put any buildings in those parks, just, you know, keep them pretty undeveloped. So if the river floods it, it's not a big deal, water goes down, everything's okay. Maybe there's a little cleanup, but it's not such a big deal as flooding a bunch of people's homes. I would also, to deal with the permeability issues, like in my neighborhood, we're building rain gardens. So I would build some rain gardens and just do any structure and other structures to increase permeability. Now, I've seen some not really extreme rainfalls, but I've seen it rain pretty hard in my neighborhood, and I go out and look at the rain gardens, and they're maybe a little bit full of water, but they drain pretty quickly, and it's pretty amazing. They're pretty effective. And the city of Portland is doing a lot of things like that as well to increase the permeability and deal with stormwater before it gets to the river. So I would put more green space around the river. Maybe build levees for areas where it's really hard to move something. Maybe if it's a historic building or a historic neighborhood that people really want to protect. And you can think of some more. So if you want a quick idea of what flood mitigation and storm rainwater management looks like in Portland, here's a rain garden in Portland. The water flows from the street through this little inlet here, and all these plants help soak up the water. It also can get in from the sidewalk here, and this very permeable area tries to make up for all the impermeable areas around it. Because Portland's pretty urbanized, it's got a lot of impermeable surfaces, it's got a lot of pavement, it's got a lot of sidewalks, and it's trying to manage its rainwater before it gets to the river. So Cedar Rapids could do similar things. I'll put that YouTube video in the comments for this YouTube video. So you can go watch the whole thing yourself if you'd like. So rainfall events, page 7. In this activity, you've seen that the higher air temperatures cause more water to evaporate into the atmosphere. Remember, we talked about like having a steamy shower. You get inside your bathroom and it gets really warm and you get a lot of water vapor in the air. Well, as our climate warms, the same thing's going to happen to the air outside. And just like the water condenses on your mirror in the bathroom, water's going to condense in clouds in the sky, and eventually many of those clouds, those tiny little droplets of cloud, will get together and fall as rain or perhaps snow. As more precipitation falls, more severe flooding can occur. So the more water that's coming out of the sky, the more water is going into our rivers, and the more flooding might happen. This has led to many cities expanding their flood hazard zones, as you saw with Cedar Rapids on the previous page. With all states in the U.S. seeing floodplains, will all states in the U.S. see floodplains expand in the coming years? Are some states at a greater risk of extreme flooding damage than others? Look at the map below that you saw in the first saw in Activity 2. The map shows the trends in flood magnitudes throughout the U.S. According to the map, which region of the U.S. has experienced the largest decrease in flood magnitudes since the 1920s? Let's take a quick look here. So these brown triangles represent the decrease in flooding, And there's a few brown triangles here in northern Wisconsin, but most of these brown triangles are in the southwest. So I would say it's probably the southwest that has decreased its flooding risk the most. It's just not getting as much rain, and we've heard about the droughts in states like Nevada and Utah. So I would say the southwest, but you can make up your own mind. Using relevant factors in the flood diamond, topography, permeability, precipitation, and water level, explain possible reasons for the decrease in the area you chose in question 24. Do you think the Southwest has changed its topography or the lay of the land, the mountains and the hills? Has it changed its permeability? Are there more cities? Are there more people living there? Think Las Vegas. Precipitation. Is there less or more precipitation in the Southwest? When we think of droughts, we think of less precipitation. And water level. Let's look at water level just a moment. So this is Lake Powell above the Glen Canyon Dam. It's meant as a reservoir to hold water behind the dam and serve as a source of drinking water for some of the folks in the Southwest. Well, Lake Powell is less and less full than it used to be. They call this the bathtub ring. This is where the water level used to be in the 1980s. It's been falling ever since 1980. There's been a drought in the Southwest, and the water level is falling in Lake Powell. So we've just seen one piece of evidence that the Southwest may be experiencing a drought. There's less rainfall, so there's probably less flooding. In what ways do changes in climate, such as temperature and precipitation, affect the risk of experiencing flood damage in the U.S.? Well, if you live in a wetter climate, if you live in the Midwest, where there are these more green triangles, which means there's more rainfall, and in parts of the Northeast, you're likely to experience more flooding because part of the flood diamond is precipitation. So we have more precipitation in the Midwest and parts of the Northeast. Maybe a little bit of the Southeast too, but mostly the Northeast and the Midwest. And there's less permeability as areas become more urbanized. With more precipitation, we might affect the water table or the starting level of the water. If you've got more water hanging around, that starting level, that water that's already in the river or the ground is higher, and so it only takes a little bit more water to flood it, versus where if you have less starting water, there's more of a safety zone. There's more water that the ground or the river can absorb before it starts to flood. So to investigate flooding trends, scientists analyzed 65 years of rainfall records at thousands of weather stations nationwide. They tracked the number of times each state has experienced a heavy rainfall event. Use the Climate Central's When It Rains, It Pours interactive below to explore trends in heavy rainfall and their impacts. The blue dots that you'll see when you hit play are heavy rainfall events. Be sure to click on the State Trends and Local Impacts tab. So let's follow the directions here and see what exactly we're supposed to do. Play the animation in the Timeline tab. So let's do that first. So we're watching for extreme rainfall events, and we're in the pre-1950s. It's 1880. We're starting to see a few rainfall events here, heavy rainfalls. But watch as we get closer and more recent to the time we've been around. We're seeing some places in the Northeast. We're seeing some places in the Southeast. A little bit over here in Oregon, some California, and a few more in the Midwest as well. What's the overall trend in the number of heavy rainfall events throughout the U.S.? Well, as we went forward, you can play it again if you want. We don't see a lot of heavy rainfall events. They're just kind of scattered until we hit like the 90s, the 2000s, and the 2010s. We see some in the 40s and the 50s, but they get much, much more common as we hit 1980, 1990s, 2000s. You can see the density of those heavy rainfall events are a lot more. So they happen more often. So click the State Trends bottom button at the top, then fill the information below for your state. Hint, use the yellow line on the graph, the white shows the trend. So here's State Trends, here's our state. So the number of heavy downpours in Minnesota has gone up, and then it's on the rise here. You can see the trend line, or kind of the average of all the years here. It's on the way up. It's been down the past couple years, but it also doesn't have recent data up to 2020 on it. In my state of Minnesota, there were how many heavy downpours in 1960? Okay, if we go down here to 1960, it's about, I'd say about 7. You can make up your own mind. And how many heavy downpours in 2010? Well, if we go across here, it's about 8. If we would have looked in a different year, it might have been more, but it's gone about 8. Now click the Local Impacts button on the interactive map. Describe some of the impacts of heavy downpours that occurred in the Midwest. Hint, look at 5, 7, 8, and 9. So let's look at local impacts. And hey, there's Duluth. They got 8.1 inches of rain in 2 days. That's pretty incredible. Just for perspective, that's 8 inches. Between my fingers is 8 inches. That's 27%, or almost, or just over 1/4 of the rainfall, 1/4 of the rainfall they usually get in a whole year in 2 days. So there were $100 million of estimated damage, 450 homes were evacuated, 14 animals were killed at the Lake Superior Zoo, and 670 miles of affected highway. It also damaged a park, one of my favorite parks, as I like to visit Duluth. 8 is in Iowa. They got 9.2 inches of rain in 2 days. That's 1/4 of their usual precipitation in 365 days. They got in 2 days. So that's crazy. All their stormwater systems weren't set up to handle that. So let's look at 5. That's Chicago. 160,000 people lost power. They had a similar situation as Duluth. They got about 8 inches of rain, which is over 1/4, almost 1/3 of their annual precipitation in 2 days. They had $34 million worth of damage, 6 to 9 feet of water in people's basements because large-scale sewage overflows happened. So that's when the sewer system fills with water and all that nasty sewage backs up into your basement. It's really gross. You don't want that to happen. But that's one of the risks in having floods, more flooding, is more sewage backup. So click the last button when you're all done. When you want to download it, click Show My Work. When you're on Show My Work, you'll see all the answers to your questions. You don't see mine because I'm in teacher mode. You want to click this little button in the upper right-hand corner. You'll see a menu. It's different on mine than it'll be on your screen. That menu will have an options bar at the very top. Click that options bar, then click PDF. Go back out, and then click Notability, and then you can download it to Schoology. Thank you so much for watching. This is Dr. B signing off on Activity 5 of the Flood module.